Welcome to lesson 97, using a recursive rule to generate a sequence. Ooh, I'm excited about recursives. They are another magical sequence of numbers. And in this one, we're going to recognize the first term in the sequence. That's super critical. And we're going to use that first term to determine the other terms that come after it. So what comes next and next and next. And finally, we're going to use substitution from the previous term, using the recursive to determine the value of the following terms. So what does this even mean? We're going to go back to looking at our fish example and looking at that pattern, that sequence that started growing, and figuring out, does this mean this is a recursive sequence? So what would the first, we're going to just put down, just we have it, just like last time. We had the first set of terms, 1, 2, 3, 4. And we know these are the number of orange tiles. And the first numbers in our sequence were 2, 4, 6, and the next one will be 8. So does this represent a recursive sequence? Let's go into our notes. Read along with me. A recursive rule for a sequence defines the nth term by relating it to the ones before it. So I need the number before to figure out what's coming next. So this is a little different from the explicit rule, because in a recursive, I cannot find a specific term directly. So that's what's different here. I can't just go and get to the 100th number. I have to actually complete the sequence out to figure out the next one. Let's look at this example here. So this rule over here, where f of 1 is 5. So we need that. We need that first term to be able to identify it. That's our starter, our initial. So these are other words you might see. And we're going to have a rule that's basically telling us we need the number before. So n minus 1 means the one before it, the previous. And then something's going to happen to that number. So starting off down here, here's our rule. So f of n means I take the number before it and I just add 2. So if I start out with 5, I'm going to have 5 and I'm just going to add 2 to it. Now I have 7. So for the next term, I'm going to take the 5 before and I'm just going to add 2 to it to get 9. And if I want the fourth term, I have to take the 9 and add another 2. So you're seeing here all that's happening in this pattern: 5, 7, 9, 11. I can define it as the one before it, 5 plus 2. If I want the next number, 7 plus 2. If I want the next number, I would do 9 plus 2. So I always need the number before it to figure out the next number. So in a case like this, if I wanted the 10th number, I could define this, f of n, as I need to know what the 9th number is. And then I know I'm just adding 2 to it. So if I want the 10th, I have to find the 9th one, f of 9, and then I can just add 2. That's the goal here. Okay, so let's try this out. We're going to write the first 5 terms in the sequence. We're not going to do this as a guided practice. Instead, I'm going to do this with you. So I'm going to have my t-chart. Here's n, and I want f of n. And our rule is f of n is equal to the one before it, the previous, plus 3. So what am I starting with? That's why I need this number. That's my start. So I'm going to start with 35. And my rule is telling me I'm going to find the second number, I need to find f of n minus 1 plus 3. Okay. So if I want 2, I need to find f of 2 minus 1, which is the same thing as f of 1, plus 3. I know what f of 1 is. F of 1 is 35. So I'm going to do 35 plus 3. And if I want the next number in the sequence, I'm going to do the same thing. I'm just going to take the number before it, and then I'm just going to add 3. So mathematically, f of 3 is equal to f of 2 plus 3, or 38 plus 3. That gives me 41. And we will do the same things. We know what the next ones are going to be. So f of 3 plus 3, or 41 plus 3, that's 44. And f of 5 is equal to f of 4 plus 3, which is the same as 44 plus 3, or 47. And those are the first 5 numbers in our sequence. I would have that just written down just as a list. So our sequence would be 35, 38, 41, 44, and 47. So that's our work for today. And yes, it does feel like a lot of steps. I know in your mind you're thinking, but why can't I just keep on adding 3? Yes, we can do that on the table, but I also want us to get really used to being able to represent those recursive formulas and being able to substitute them as well, so we can see how our answers are derived. That's it for today's lesson, Math Marbles. I will see you in the next sequence lesson. Be well.